Welcome to Brain Vision.
Now, really what this question is asking, if delta L copper can equal delta L steel. And you can tell that this is what the question is asking because we want to see if the rods will remain 5 centimeters apart at any temperature. Therefore, any delta T, their delta L's will be equal, right? If they start 5 centimeters apart. So why don't we use these expansion equations for C and S and see if we can prove this. So for delta LC, we should get that delta LC is equal to LC times alpha C delta T. Delta LS is going to be LS times alpha S delta T. The delta T's will cancel out. We'll have LC, now alpha C, linear expansion coefficient of copper, is going to be equal to 17 times 10 to the negative 6 inverse degrees Celsius. The other side we have LS, and then alpha S is going to be 11 times 10 to the negative 6 inverse degrees Celsius. We can kind of cancel out these 10 negative 6 to see them a little clearer. So we have 17 LC is equal to 11 LS. So yes, this is in fact possible on really two requirements. One, we need the linear expansion coefficients to be constant so we can make this assumption anyway. And two, we need appropriate LC and LS to make it equal. And that is the topic of part B. So part B asks, okay, which one must be greater? So let's return to our original equation. 17LC is equal to 11LS. We can think of this multiplication as balancing out the 11 and 17 to make them equal, and therefore it's pretty clear to see that LS must in fact be greater than LC. So we can go one further and make the assumption that, well, not really an assumption, but say that LS minus LC equals 5 centimeters. It's in the question that they're different. The difference in length is 5 centimeters. We can solve this simultaneous equations by plugging in this new value for LS. So 17LC is equal to 55 plus 11LC. Solve that LC is equal to 9.17 centimeters. And of course, if you look at the other equation for LS, you just add 5 to that, and you should see that LS is equal to 14.2 centimeters.